Today you're going to be learning about prisms and how to find their surface area. Before we can start though and talk about our surface area of prisms, we probably need to go through and figure out what is a prism. And a prism is a solid that has two bases and then lateral faces. So the two bases are the same. And you can think of it that the two bases are stretched apart from each other. Now, a special case of a prism would be like a cylinder. A cylinder, we know the bases are circles, and those circles are stretched apart from each other. If you think about a Pringles can, that's a prism. It's a special case, though, that it's a cylinder. To give you an idea of a true shape, you can think of a box. A box is a good one. If I have a pentagon, and then I were to connect and then connect all of my corresponding vertices. So as you guys can see, it's kind of like drawing a 3D box, but this time I have a pentagon. As you guys can see, the two bases are my pentagons, and they are stretched apart from each other. So obviously we've kind of already gone into a little bit more depth here. Our base in this picture is going to be a pentagon. Which we know are two congruent shapes or polygons. We'll just leave it as shapes, just to give it an overall broad term. The part that's stretched apart, so that's not the base, are our lateral faces. Easiest definition, not the base. And then we have lateral edges, which, as you can guess from the lateral faces, these are the edges that are stretched apart. Our lateral edges, so for instance, this one's a lateral edge. These are edges that connect our two bases. Just draw this shape here. So again, lateral face is the part between, it's the face between our two base shapes. So in our case, it's a rectangle. And then a lateral edge is connecting. It's an edge connecting our two bases. Just as a double check, in case you need to write this down, a vertice or a vertex is where our edges meet. So if I'm looking at my picture, right here, this point, we know is a vertice or a vertex. We've kind of talked about this before, dealing with angles. It's where our angles meet. This is the same thing when we're going to a three-dimensional shape. Okay. There are other special cases. We have a right prism and an oblique prism. Basically, the only difference, an oblique one is leaning. So it's like the Leaning Tower of Pisa. It's slanted. Okay, so this is the basics for any type of prism that we're dealing with, or any type of three-dimensional shape. When we're talking about the lateral faces, the lateral edges, the base, whether it's oblique or not, these terms apply to any three-dimensional shape, whether it's a prism, whether it's a cone, anything of that nature. Okay, moving on. There are two different types of surface area that we're going to be talking about. The one is the lateral surface area, and then the other one is just our basic surface area. With our lateral surface area, we know that this is just going to be with our lateral faces. Think about it. We just talked about lateral faces, and now we're just talking about the lateral area. But we want the total surface area, so we're going to just label that surface area. Don't worry about having to find the lateral area. You'll do it in this formula anyway. Our surface area is our lateral area plus 2 times the area of the base. Because with the prism, we know that we have 2 bases, but if the bases are congruent, so I know that I can just find the area of the base. Something to note, this lateral area is going to be the perimeter of the base times the height. So I'm just rewriting this so you guys can see what the lateral area equivalates to. Let's look at an example here. Just so you guys know, you're going to be doing a lot of three-dimensional sketching. You'll get used to it, and you'll figure out it gets better over time, just like your circles. Anything that's hidden is with a dotted line. So if you see I just did that back one with a dotted line, I have 2 right triangles and they're stretched apart. All right, looking at this prism, I want to find the total surface area. So I'm going to use my formula. Okay, so we are told to find the perimeter of the base. Looking at my picture here, my right triangle is my base. Notice from here to here is 3, here to here is 4. I have a right triangle, so I should be able to figure out my hypotenuse based on Pythagorean theorem. In this case, I know that I have a Pythagorean triple, so I'm just going to go ahead and put the 5 there because I know it's Pythagorean triple. Otherwise, what we would do to find the perimeter is do the 3 squared plus 4 squared equals c squared, and we'd find out that c equals 5. Okay, so moving back to our lateral area here, the perimeter of the base, well, what's 3 plus 4 gives me 7. 7 plus 5 gives me 12. So I have my perimeter times, well, what's the height? How far are my 2 triangles stretched from each other? I see that I have a 10 here. This 10 is from this point here all the way up to this point. So that must be my height. Here's the tricky part. Some of you might not remember your formulas to know what the area of a triangle is. So you will get a list of this in class because we'll be working with these types of problems a little bit more in depth. So in this problem, the area of a triangle is 1/2 times the base of the triangle times the height of the triangle. Okay, so we're just going to simplify this. 12 times 10 gives me 120 plus 2 times 1/2. What's the base of my triangle? That's 3. The height of my triangle is 4. Notice it wouldn't matter if you had those switched around. The answer would still be the same. I'm going to slide this over here a little bit. 120 plus 2 times 6. So I've got 120 plus 12. And my final answer is then 132. You need to have a unit. In this problem, we don't have any type of unit, so I'm just going to leave it as units squared. Because we're talking about surface area, our units are squared. Okay, so looking at this, I'm going to give you another problem, and I want you guys to work on it on your own. On your own, what that means is you're going to be asked a question. So you'll find the lateral area and your area of your two bases, and you'll have to find the surface area. You have to answer it, and then I'll go through it with you. I'll give you an easy one even. So you need to find the surface area of this prism. Looking at this, I know that my base is a rectangle. I can see that it's got 2 right angles and my 2 sides are congruent. So I need the perimeter. So I've got 6 plus 6 plus 3 plus 3. That's 6 times 3, which gives me 18, times my height of 12, plus 2 times the area of my base. Area of my base, notice I gave you an easy one. It is just 6 times 3. So looking at this, I now have 216 plus 12 times 3 gives me 36. Oh, I'll put a label here. Say we're in inches. So then I get 252 inches squared as my surface area. Final answer.